Everyone, I hope you're having a great spring break. Welcome to my short tutorial. I'm going to be walking you through the homework, the last section of this slide, loading the example data and running it in Tofware. So this is data from the ELF. This is our unit mass resolution, PTR TOF MS, and this is one of the instruments we'll be using at the chamber experiment next Friday, April 4th. So we're just going to go through this homework step by step, and hopefully it'll be super straightforward for all of you. So you want to start by opening a fresh Igor experiment. And then we need to put our Tofware into there. So you want to navigate to wherever you've installed your Tofware to. For a lot of people, that's in Documents. I'm now navigating through to Wave Metrics. And I'm loading in Tofware 401. You'll be loading in Tofware 403. And so it's easy, just do a drag and drop. So hopefully you can do that. We can close this once my computer lets me. Perfect. And then we have sort of the prompt for getting a Tofware analysis panel up. So you want to be in batch mode. So that's our second one here. And all of these can be not defined. And we're going to click open files. And then I'm actually just going to click cancel here because I'm going to show you how to open files from within the panel. So the left side I like to think of as more of our analysis side, and the right side is what we're doing the analysis to, which I'll explain a little bit more soon. So we're going to go up to this add file button, and I just want to make sure I add in the exact same files that I gave you. So I turned this into a zip file, so hopefully we all have the same things here. And okay, for some reason the command's not working for me, so I'm just going to go through and select them really quick and click open. Perfect, so that's quick and easy. And so you want to make sure that all of your files on this side are selected so that whatever you do on the left side happens. So that's what I kind of mean. The right side is what you're applying the analysis you do on the left side too. You can also analyze certain parts of your data only and make something called a to-do, which is not something that we're going to look at today, but just something to be aware of. So, but right now we're just looking at all of our files. And I just want to point out the different file lengths. So our 3600 files, this is when I was acquiring data from the office, and the 72s and the 62s are calibrations and zeros. So either sampling from the cal gas tank or from our zero air generator. And now our left side is more populated. So we have file info, user data, the log, our plotting panel, workflows, miscellaneous. So under the miscellaneous, I want to go into settings. So you want your units to be in ions per second for both. I think that is the default, but just in case it's not, make sure you have that. And then these next two things are definitely things you have to change if you have not used Tofware before. So the first thing is this experiment was done UTC -6 here in Boulder. So you want to change, you're probably starting with a 0. You want to change that to -6, which is not really that important for today because we're just doing an overview, but this will be important in your life in the future. So make sure you're putting it into your correct time zone. The other thing is the data saving model. It says advanced, but no, this is very basic, and this is something that you want to be doing from day one right now. So I want to make sure that everyone is on save to _p files. And that we're using the instrument function files. You just want your box to look exactly like my box. And I want to show you quickly what this means. So when you are doing your work, so the ELF is, I'm collecting data folders from the ELF per day. And if we go in, so the ELF gives you .h5 files and .csvs. We almost never use the CSVs because we want to do our own processing. But then from the H5s, we're going to do processing. In the IF folder, this is going to be the original files. Nothing is going to change them. They're going to be preserved in their original state. And then in the processed are all the different things that I've done to my original files is what's going to be here. And now we have _p. And so that means processed. So that is what is happening from these functions. settings from these settings. So definitely follow this. And we don't need a workflow. So as I mentioned, we're in unit mass resolution here. So it's very unlikely that we are going to be a whole M over Z away from where we're supposed to be. And we're just going to do a quick sanity check later. But otherwise, we could load in a workflow, and that would be by going through change here, load new, and navigating to wherever your workflows are. So again, that's probably going to be under that same documents, wave metrics way. And I have a bunch of workflows here. I also have other versions of Tofware. So I have a 3.2.5, which offers me a different workflow. So this will be up to what the aims of your analysis are and what makes most sense. Now let's navigate to the plot folder. So I already have these M over Zs here, and I think that you might not. So I'm going to show you how to get them. So you want to go to fit and integration. So this is miscellaneous fit and integration. And so you want to select fully constrained fitting. So the first button is selected, and because that one is selected, the next one is ignored. So these three lines here are ignored. We did not set a baseline or constraint isotopes or anything, but you can leave those. But the main thing is you want to integrate nominal masses. So I'm just going to redo this here, and that's fine. Just to make sure that we're on the same page. So this is what you're going to have to do. And while these files are updated, let's jump back to Chrome and go over some things. So the first task that we're going to do here now is plotting the average UMR mass spectrum, and the second one is plotting the time series of M over Z93, quote unquote toluene. And I just want to communicate and emphasize that it's in quotations because the alpha is only in unit mass resolution, so we're only associating M over Z93 with toluene. It's not certainly or totally toluene. And I just want to show you all a really great resource that you may or may not already know about, which is the PTR library. I strongly recommend that you go to this page and you bookmark it. And from here, you can look at apparent ion mass, you can look at its elemental formula, its composition, and its name, and this matches all up for PTR. And so we can do a quick little sanity check and confirm that in the library at 93 we see toluene, and that is the case. And what you can see is that at 93 it really is mostly toluene. We have this other one here, chloroacetone, but it really is mostly toluene on all these different publications, and in the context of our experiment it is most likely toluene, but we can't say for certain, so the quotation marks still exist. So let's see where we're at. Okay, that looks like perfect timing. It finished in 1.5 minutes, so it shouldn't take too long. We don't have a lot of data here. And let's navigate back to our plot folder. And again, make sure you have all these files selected, and we want to do the stick spectrum average. So I'm going to select that. And for some reason, I got 1HR, so I'm going to unselect that. And I want to plot the UMR data, 391 peaks. That sounds about right. I'm going to delete the unused peak here because it should just get rid of this one HR peak that shouldn't exist because the alpha is not in HR, and I'm going to plot that. So you can follow suit depending on what exactly you see. So now we get a mass spectrum, and this is where I'm going to recommend that we do our sanity check and ensure and confirm that, yes, a mass calibration was not needed here. Now, if this was for research purposes, I would certainly do a mass calibration. I would refine the peak width and shape, but these are all things that we will learn in class together in 2 weeks or so. So I just hit Control-I shortcut to pull up the cursors, and I'm going to drag and drop it on this large peak. And what you want to be looking at is this X55. You don't want to be looking at 0.48. And the reason for that is that our first value is at 7. So there is going to be a lapse different. So this represents what the actual M over Z is. So now we can see that our largest peak is 55, and our second largest is 37, and these are the two largest by far. So that's good. That means we're not shifted over by full M over Z in either direction. 55 and 37 are where we expect them to be. In PTR, we definitely expect these to be the two largest, and in the ELF, it could go either which way on which one's largest based on the specific instrument itself. And for our ELF, 55 has always been the largest as long as I've used it. So we feel good about this. We're in the right spot. So you could be done here, but this graph is pretty ugly, so we are not going to be done. So you need to right click on the actual trace, and what I'm going to show you is how you're going to understand where this data actually is in your data browser. So you're going to right click and go show into data browser. And now we can understand that we have plotted MSS underscore all against MSS underscore base, and that these are housed in our HDF files 0 to 14 folder. So I'm going to close this automatic one and I'm going to go Windows, New Graph, and I'm going to make a better one. So this is our Y wave. So we are definitely going to want the all here. And then on our X, we can take the base and nothing shows up here. So that means they're the exact same size. So we've definitely selected the right thing. So we're going to go do it. So the first thing that I like to do for a mass spectrum is if you double click on this space, you can change this to 6 to 0 just to make it look like a classic mass spectrum. And I prefer a grayscale for this. And we don't have a busy mass spectrum, so I like to do a 1.5 just to make it a bit thicker. The next thing you notice is, there's no action going on this right side of the x-axis. So let's change the range. Let's go 50 to 150, do it. And there are a lot more things you can do from here to make your graph better for your homework. I would recommend doing axis labels. I would recommend considering how can you show the data in a way that is valuable. So right now you have 55 being really big. Is your idea to just delete 55 from your wave and note that in your answer that you did that? Or is your idea to go into a log scale just so you can see these different signals? I don't know what your idea is. It's up to you. But hopefully from here you can develop something a bit nicer, or you can just change the scale. Up to you. Looking forward to seeing what you come up with. So that is task number 1 completed. I'm not going to save this. Task number 2, we wanted to plot the time series for M over Z 93. So we want to go back to our analysis panel. Again, all of our files are selected, and you could scroll through here and you can select 93, or you can go nominal. And this is most useful when you have a longer list than just one, because otherwise you're like carefully selecting multiple and you're like holding down your control, and that's really annoying. So a comma separated list is great. I'm just going to type in 93 and hit continue. Now it's selected in here, and we can see that at this number of selected peaks, it's just 1. So I think our list worked, and I'm going to go under time series, and I just want to go for selection. Great. So Tofware applied an automatic conversion. For research, I would do an actual calibration, but they just put us into PPB here. Yeah, I would not use theirs, but that's okay for now. So we have our time series going across. We can see that every hour we are getting to the 0 period. So that's great. And what I'm going to do is just copy this into a new graph to show you that feature. So again, I right clicked and did that. And so great. So you can work with this from here to turn something in for your homework. You can also right click and go into the data browser and see what files you have, and do it the other way with the Windows new graph, but it's really up to you. What I'm first going to say is you do not need to worry about getting rid of these zeros periods or this noise. If you want to get rid of some of the noise in a super quick way, you can right click again and just do a quick little smooth, but definitely don't worry about the zeros. The other thing that I will just quickly mention for context is that this was a catalyst cycling experiment, so you can see a change when the catalyst was changed. I was cycling around 440 was when things changed. So yeah, hopefully you're all good to go on your homework. Let's flip back and just sort of look at this again. So we loaded the data. We did our settings really importantly. We looked at the processed and instrument function files. We changed our time zone. We plotted our average UMR mass spectrum, and we plotted our time series of M over Z93 for our homework tasks. Good luck. Feel free to come to office hours on Wednesday if you have any questions. Otherwise, I will see you at class. Thanks so much for your attention, and I hope this helped.